back to Chemicals TV, and in this video we're going to talk about binary ionic compound that involve metals with variable oxidation states. Now, in our previous video on writing and naming binary ionic compound, we have done ionic compound that involve metals with single oxidation states, like the group 1 element, the group 2, and the group 3. Now, like the group 1 element, which are what lithium, the what sodium, and what potassium, they all have what the +1 oxidation state. Now, for the group 2, like the magnesium and the calcium, they all have what the +2 oxidation state. Then for the group 3 elements, like the aluminium, they only have what +3 oxidation state. So each of these metals can form just single ionic compound with what non-metals, right? So these are stuff we have done. So we have done videos on writing binary ionic compound and also naming them too. If you haven't watched those videos, I will link them at the description below, so I can go check those videos out, because you are still going to see questions based on those videos there, right? But in this video here, I'm going to share with you metals with variable oxidation states. Now, because they are variable oxidation state, they can form multiple compounds with different non-metals to form ionic compound. Now, an example of these metals that can form variable oxidation state are the transition metals, like the one we have here, metals with variable oxidation states. Now you commonly find them in the D block elements. Now here we have the cation systematic name. Here we have CrO3+. Now it means that chromium can lose 3 electrons. Also it can also lose 2 electrons. That is meaning, because it can possess more than one oxidation state. So you must include their oxidation number instead of Roman figure. So here we're going to be chromium 3 and chromium 2. Unlike sodium here, sodium is just sodium ion. It's okay, sodium ion. It's not sodium 1. You get, it's not sodium 1. You cannot see something like this. Now the main reason why it's like this, because sodium can only have +1 oxidation state. Now Ca2+ can only be calcium ion. Do you get that? Now you will not see anywhere where you say calcium 2. Do you understand? Like aluminium here, Al3+, can only have aluminium ion. Now you cannot see you want to be aluminium 3. Now do you know the reason why? Because aluminium only have single oxidation state, which was +3. Now you can lose you're going to lose 3 electrons. You have to obtain the octets, right? Now, but for the transition metals, now they can lose more electrons. Do you get that? So now, because they can lose more electrons, what happens here? They can have variable oxidation states. Now here we have magnesium 2+, magnesium 3+, now iron 2+, iron 3+, cobalt 2 and cobalt 3, copper 1 and copper 2. You get. So when these metals form or bond with non-metals, now they tend to use those variable oxidation states. Now because they have variable oxidation state, they are going to form variable ionic compound. Now, for example, if copper bond with with oxygen, right? Now when copper bond with oxygen, now a question will be asked, what is the oxidation state of copper that bond with oxygen? You get. So remember, copper can form multiple oxidation states. Like now, if copper 2+ bond O2 minus, remember oxygen only 2-, right? Now it's going to form an ionic compound. Likewise, if copper 1+, which is copper plus, like O2-, now it's going to form another ionic compound. So if these two bond, here we have Cu, here we have 2O, which is 2. Now when they bond here, when they combine, here is Cu2O 2, right? Now, but you must express it in your simplest ratio. So we're going to do what? CuO, right? The same thing with this guy here. Here we have Cu, which is what? 1, O, which is what? 2. So this one here, this one what? Here. So what happened here? Here we have what? Cu2O1, right? So which is going to be Cu2O, right? So copper can form multiple compound with what? Oxygen. So here we have CuO, here we have Cu2O, right? Now, the oxidation state of copper here is what? +2. The oxidation state of copper here is what? +1. So now when I see their name, here we have what? Cu2O and what? CuO. Remember, now the copper that forms one here is what? Copper what? 1, right? So we're going to be copper 1 oxide. Now the main reason why it's copper 1 oxide because the main oxidation state of copper here is what? +1. Because here we have Cu plus like what? O2 what? Minus, right? So when they combine, they now form Cu2O, right? Copper what? 1. Why is it going to be what? Copper what? 2 what? Oxide. You see the reason here because here it's going to be Cu2 plus like what? O2 what? Minus. So when they form, it's going to be CuO. You get? So now, when you are naming compounds that involve metals with variable oxidation state, you must be careful to know the oxidation state in which what that the oxidation state of that metal that form that ionic what compound. And let's say for chromium and what for chromium. Now if chromium here is CrO3 plus slash what N3 what minus, right? And here we have CrO2 plus like what N3 what minus here. So that if you want to write the ionic compound, how are you going to do that? Here we have Cr, which is what 3. Here we have N, which is what 3. So move here. So move here. What happened here? Here we have CrO3 and what 3, right? So now if you should express it in what in their simple ratio, here I would have CrOn, right? So the oxidation state of chromium here is what ion. We use what 3 plus, right? Here, what are you going to get? Here we have Cr, which is what 2. Here we have N, which is what 3, right? So if you move one here, they move one here. What are you going to get? Here we have CrO2. So here we have CrO3 and what 2. So that is chromium can form bond with nitrogen to have what different what ionic what compound. So how do you name them? Now, therefore, you have to understand that chromium here is having what +2 oxidation state. So it's going to be chromium 2 nitride, right? Chromium what 2 what nitride. Why is it going to be what chromium 3 what nitride? You get? So you must be careful when you are writing compound what with variable what oxidation state, like when writing their name. Parts for iron. So here we have when iron combine with chlorine minus here, and here we have iron 3 plus combined with what Cl minus. So you're going to form variable compound here. So here we have Fe, which is what 2. Here we have Cl, which is what 1, right? When some move here, we have Fe1Cl2, right? So here we have FeCl2, which is so now when they combine, this one move here, this one move here. So here we have FeCl2, right? Now let's look at this one here. Fe, which is what 3. We have Cl, which is what 1. So when they combine, what are you going to get? Here we have Fe1Cl3. So iron can bond with chlorine to form FeCl2 and what FeCl3. So what is now their name? what is their name? So here we have FeCl2. Now this is going to be because the oxidation state of iron here is going to be 2. So it's going to be iron 2 chloride. It's okay, iron what? 2 what? Chloride. Then here we have FeCl3. Here we have what? Iron 3 what? Chloride. You get that? So you must figure out the oxidation state of that metal that form that ionic compound, and you must actually put that oxidation state while naming. You get? So I'm going to leave some example, some insights for you to try and what name this compound yourself. So I'll be leaving you with this set of questions here. Now, based on what we have done, you should be able to name this compound here. You should be able to know the oxidation states of each of the metals that form the various ionic compounds. So try and do that.